Hi, I'm Papia. In this problem, we have this infinite series given to us. We have to approximate the sum of this series by using first 6 terms. Now, notice that to find exact sum, we have to add the terms for various n values up to infinity. So, we cannot always compute the exact sum. We can approximate by using a finite number of terms. That's what we have to do. So, first thing you should notice is, given a series, it doesn't always converge. So, not always it will have a sum. So, let's check if this series will converge, and then we can approximate its sum. So, notice that this is an alternating series. And you know the feature for a series to be alternating is that it has a -1 to the power n or n plus 1, that term. And it does. Also, the remaining terms, 5 over n factorial, is positive. So it is an alternating series. So we can do alternating series test. Okay, so what is the test? Recall that we have to check if the limit of an, so the positive part, which is 5 over n factorial, we have to check if the limit is 0. So is the limit 0? Well, n is approaching to infinity, so the denominator is getting big. It's going to infinity, so the whole thing is approaching to 0. So that's the first part of the test. Second, we have to make sure that the n is decreasing. And it is, right? So the sequence 5 over n factorial is decreasing. Because if you compare the two terms, if you compare the n plus 1th term, 5 over n plus 1 factorial, versus the nth term, 5 over n factorial, which one is bigger? Well, you see the denominator of this one is bigger than the denominator of the other one, and so the whole thing is smaller. Right? So the n plus 1th term is smaller than the nth term, and therefore it is decreasing. So it checks. And so alternating series test says that your series converges. Since the series converges, we know that there is a sum. Okay, so now we have to find the approximate value of that sum using the first 6 terms. All right, so let's write down the first 6 terms and see what the sum is going to be. Okay, so this is our series n equals 0 to infinity, -1 to the n, 5 over n factorial. We're going to approximate by first 6 terms. So let's write them down. So how do we know all the terms? The first term is the first n value that's given to you. So it starts at n equals 0. So you plug in n equals 0, and whatever you get, that's the first term. Okay, so let's see. N equals 0, -1 to the power 0 is 1. So you get 5 divided by 0 factorial. Okay, then what is the next term? You plug in the next integer value, which is n equals 1. So plug in n equals 1, you get -1 to the power 1, which is negative. And you have 5 divided by, remember you're plugging in n equals 1, so you get 1 factorial. And you continue this way. So the next term will be n equals 2. Okay, so when you plug in n equals 2, notice this becomes positive. So next term is positive. 5 divided by 2 factorial. Okay, so n equals 0, 1, 2. Next will be n equals 3. Plug in n equals 3, -1 cube is negative. So you have minus 5 divided by 3 factorial. So how many terms do we have? 1, 2, 3, 4. We need 2 more. Okay, so plug in n equals 4. You get -1 to the power 4 is positive. And 5 over 4 factorial. Last term is for n equals 5. Again, you get a negative 5 divided by 5 factorial. So we have 1, 2, 3, 4, 5, 6 terms. So we have to add all these terms, and whatever value we get, that's the approximate sum of this series. Okay, so let's use a calculator, plug in these numbers, and figure out the sum. Okay, so 5 divided by 0 factorial. If you want, you don't have to plug in 0 factorial. You know 0 factorial is just 1. So let's write one more step. This is 5 divided by 0 factorial is considered 1 minus 5 divided by 1 factorial, that's 1, plus 5 divided by 2 factorial. You know the definition of factorial. 2 factorial is 2 times 1, which is 2. Okay, so 5/2 minus 5 divided by, well, what is 3 factorial? It's 3 times 2 times 1. So it's 6. Next, plus 5 divided by 4 factorial. 4 factorial is 4 times 3 times 2 times 1. We already know 3 times 2 times 1 is 6. Times 4, you get 24. And the last term, minus 5 divided by 5 factorial will be 5 times 24, which is 120. Okay, so the approximate sum is 1.8333. Well, we have the approximate sum, but let's figure out how good this sum is compared to the exact sum of the series. So recall that there is this alternating series remainder theorem that we can use to figure out what the error is, or how far away this approximate sum is from the exact sum. So in order to do that, let's call this the exact sum of the series to be S. Okay, and the approximate sum that we just received, we just got here, that is Sn, depending on how many terms we have added. Now notice that we added 6 terms, right, to get our approximate sum. But we started at n equals 0 and we went up to n equals 5. So the approximate sum is S5, even though we added 6 terms because we started at n equals 0. So S5 is the approximate sum, which is 1.8333. And then if you notice that the 3 goes on, so let's use another decimal place so that when we find the error, we can round it up to 4 decimal places. Well, now the alternating series remainder theorem says that if you take the difference of these 2 sums, so this is the exact S and this is the approximate, the difference, the absolute value, is equal to the remainder. And remainder is what gives us the error calculation. Now this is the error. And the theorem says this quantity will be less or equal to the next term of the series, which is A6. Well, let's figure out what A6 is. So we went up to S5. So remember, that was when n equals 5. So now we have to figure out the following term. So n equals 6. So look at our series, plug in n equals 6. So what do we get? For n equals 6, we have -1 to the 6, so positive 5 divided by 6 factorial. Okay, let's see what that value is. 5 divided by, remember 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So 6 times 120, because 5 factorial was 120. Okay, let's plug it in your calculator, and this is approximately 0.006944. Well, so the difference of the two sums, the exact and the approximate, is less or equal to this quantity. So this is the error right here. Therefore, this tells you that the exact sum S lies between the S5 that we got between 1.83333 minus this quantity and the sum S5 plus this quantity. So in other words, what I'm saying is S lies between the two values. So let's plug them in your calculator and you see that the exact sum S will lie between 1.8264 and 1.8403. So we have our approximate sum and we also know how accurate that sum is compared to the exact sum. Thank you.